Okay, let's continue with some more examples. So this is another example of combining logs. So if we had the log base 3 of 5, and we added to that the log base 3 of 8, and then subtracted the log base 3 of 2, and we wanted to write this as a single logarithm. Okay? There are no coefficients here, so we don't have to worry about bringing anything up to a power. So working right to left, I'll deal with the addition first of all. So all of these are in the same base, so we can combine them. Right? These first two will combine to the log base 3, and now of the product, 5 times 8. And then we'll subtract off that log base 3 of 2. Now this is equal to 40, okay? So, and I have a subtraction. So what I can do, when I'm subtracting logs of the same base, again I can combine them to be a single log. 40 will become the numerator, okay? And then 2 will become the denominator via the subtraction. Which we can simplify this now to be the log base 3, and 2 goes into 40 20 times. Let's do another. Example, 2 times the log of x minus 4 times the log of x plus 5 plus 1 over x times the log of 3x plus 5. Now, let's apply the power rule first of all. Okay. So this 2 can come up to here. This 4 can come up to here. And this 1 over x can come up to here. So let's see how that looks now. So we have the log of x now squared, because we've moved the 2 up, minus the log of x plus 4, now to the 4th power, by moving this 4 up, plus the log of 3x plus 5 to the 1 over x power. Okay, so now we can start combining. So here I have a subtraction. Okay. We have the logs in the same base. Remember, we don't see a base here, so we understand that to be base 10. So I can combine these as a single log, okay, where this argument, x squared, becomes the numerator, and this argument, x plus 5 to the 4th, becomes the denominator, plus the log of 3x plus 5 to the 1 over x power. Now I can combine these two. As a single log. It's an addition, so that means the logarithm will be a product. And I take the first one, x squared times x plus 5 to the 4th power times 3x plus 5 to the 1 over x. And remember, this is like over 1. So we could really write this as the log of x squared times 3x plus 5 to the 1 over x power over x plus 5 to the 4th. Okay, so those are examples about how you condense logs and how you expand logs. We do need to talk about the change of base formula. So let us consider this. If we have the log base, I'm sorry, I just lost my notes. Here they are. Okay. If we have the log base 2 of 16, well, we can evaluate this. We know that 16, if I take the prime factorization, that we could rewrite 16 as the log base 2 of 2 to the 4th. And why that is helpful for us is that now we have written this so the bases match, and so the answer to this must simply be the exponent. Okay? So the log base 2 of 16 is equal to 4. If we looked at the log base 2 of 32, we could again rewrite this. It's a log base 2, now not of 2 to the 4th, but 2 to the 5th. 16 times 2 is 32, so there's an extra 2. And if we do this, then again, we have made these match, so the answer must be the exponent. So if we were to look on a number line, we'd have 1, 2, etc., etc., etc. So we get up here till 16. Somewhere up here would be 32. Okay. And so this is how our number line would work. Okay. Now I hope you would also believe this, that I could take the log base 2 of any of these, and they would still fall in this order. Now we know the log base 2 of 1, well, that's equal to 0. We saw that the log base 2 of 16 is 4 from here. And the log base 2 of 32 is equal to 5 from here. So let's say we wanted to look at the log base 2 of 18. Well, 18 falls in here, and as we've renumbered this number line, so must the log base 2 of 18. So I know how to approximate this. It must be that the log base 2 of 18 is somewhere in between 4 and 5. So it's 4 and something else, a little more. And that's a good approximation for the log base 2 of 18. However, let's try and find out what the exact value would be. So the log base 2 of 18 is equal to some unknown quantity. We'll call it x. If I was to write this exponentially, I'd be wondering 2 to what power is equal to 18. Now, the variable here is in the exponent. If I want to get a variable out of the exponent, I need to take a logarithm. Let's say, for example, the natural log. So I can take the natural log of both sides. What that looks like then is the natural log of 2 to the x is equal to the natural log of 18. And then I can apply the power rule for exponents and bring this down. So we have x times the natural log of 2 is equal to 8. Natural log of 18. Now remember, x is the power that we needed to raise 2 to get to 18. And now I can solve for x, because it's being multiplied by the natural log of 2, so I can simply divide by the natural log of 2. Here the natural logs of 2 will cancel, so we're left with x is equal to the natural log of 18 divided by the natural log of 2. And this is our exact answer. So, in general, what we get then is the change of base formula. So the change of base formula says if you take the log of any base, call it a, of some number, we can always reevaluate that base. We can take the log of a different base of the argument m, and we can divide that by the log of the same base, which we've chosen, of the previous base. So in our example, we were using the different log was the natural log. So another way to rewrite this is the natural log of m over the natural log of a. And that will be helpful for us while we're doing some calculations. So for example, if we have the log base 5 of 36, I can pick whichever base I would like to work in. Okay. How about we work in the common log? Okay. So if I change the base to the common log, then the numerator is the log of 36, and the denominator is the log of 5. Or I wouldn't have to work in the natural, or with the common log. I could work with the natural log, and it would look like so. Let's do one more. We could look at the log base 2 of 10. Now, if we go to the common log, the numerator is the log here of 10. That is the argument of this. And then I have to take the common log of 2, which is the previous base. Or, if I prefer working in the natural log, it would be the natural log of 10 divided by the natural log of 2. Okay, and that should get you through your homework. So that's today's lecture. Email me if you have any questions.